Lesson 4 or 5. Now, this is actually not found in the textbook, so a lot of this is just going to come straight from what you might see in different problems, but is not necessarily addressed in the book. We have these words here that you'll see, but what we're going to focus on here is what's called directional bearing. Now, here's how directional bearing works. It's on a system that you might have heard of before. That's the north, east, south, and west system. Now, each these letters I've separated for different poles. The North Pole, here's East, South, and West. And the way it'll work is you'll get some value, and it might say that a plane flies on a heading of, say, 100 degrees. Now, if they say heading or bearing, what they're talking about is this system here. And what you would do is you would start from north, and you would work 100 degrees going from the north. So you'd start north, and you go 100 degrees going clockwise. So east is 90 degrees. 100 would be just past this, and so the plot would look like that. That would be 100 degrees there, and so you would be on a heading here. Just to make sure you understand, east is 90 degrees, south would be 180 degrees, west is equal to 270 degrees, and north is either 0, or if you went all the way around, it could be 360. So it could be either one. Now, they don't only use it as a bearing of, say, 100 or a heading of 100. They could also say north 30 degrees west. And what that means is if you see it in this form, you start with a heading going north, but then you go 30 degrees towards the west. So it looks something like this. If you plot it, you'd go 30 degrees starting from the north towards the west. And that's how you would find north 30 degrees west. And this one again is 100 degrees just as a heading or a bearing. Now, they don't have to start at the north if they give it in this system. They could say something like south 25 degrees east. And what that would mean is we would start with a heading that would be pointing towards the south, and then you would go 25 degrees towards the east. So maybe something like that. This would be your 25. And so this line, since we started at the south and we headed toward the east, would be south 25 degrees east. And so that's how the system works. You could, not that it's usually done, but you could technically even go from like the west. And most people start from either the North Pole or the south. But you could say something like west 10 degrees south. And that would simply mean you would start at the west and then you go 10 degrees towards the south. And that would be the same thing. You could write that as west 10 degrees south, or since this is coming from, you could go from the south and say this is all, so I'll do or here, south 80 degrees towards the west. You could rewrite it either way. So let's look at some of these problems of converting. It says convert north 36 degrees east to decimal degree form. Now the difference with decimal degree is you would start from the x-axis. So I'm going to first begin with this. We start at the north and we're heading towards the east. We go 36 degrees. So you go about 36 here. From the north towards the east, that's 36 degrees. Now it says convert it to decimal degree. Now this starts at the x-axis. And so now I'm going to switch terminology. Instead of saying east, I'm going to say x-axis. It would be going from here up. So now you just kind of use some spatial knowledge to figure out how many degrees is there. We know between north and east there's a 90-degree angle. And so what you could say is 90 minus the 36 would give us our angle. When you do your math here, you get 54 degrees. So my answer in decimal degree form would be 54 degrees. Let's try another. Here the problem says south 15 degrees east. We want to convert that to decimal degree. So if I plotted this, I start at the south, and I go 15 to the east. So this is south, this is east, and that's 15 degrees. Now, to convert to decimal degree, you go from the x-axis. What's the quickest way of getting there from the x would be to go downward like this. So this will be negative because we're coming downward, again, from the x. and it's negative because we come downward. There's 90 degrees here between these two, so 90 minus 15 would tell us how many degrees we headed downward, which is 75, but because it's down, you could say that is negative 75 degrees. You could list this as the answer, or again, the other way you could do this is you could come from the positive all the way around, and this would be 90 plus 90 plus 90, which is 270 plus 15. So you could also say 270 plus 15 would equal 285. And you could write your answer in this format as well if you wanted to use a positive coterminal angle. So these two are coterminal. They both refer to this spot, which is south 15 degrees east. I got two more. Now let's convert from decimal degree to a directional bearing. So 152 degrees in decimal degree, we would start at the x. This is 90, so we need to go 62 more. This would be something like that. This would be 152 degrees. And to convert it to directional bearing, usually we start at the north or the south. So if I started from the north, I'm going towards the west. How many degrees do I go? Well, I'm going from here to here, which would be just 90 less than 152. So you take your 152, you subtract 90, and we get 62 degrees. So the answer would be north, 62 degrees west. Now I got some for you to try.